been working a lot of your run. I just watched him do. I actually watched do rectangle, or actually polar coordinates and rectangle coordinates, and then rectangle coordinates back into polar coordinates. I actually watched that one first, but I didn't realize he just did one for a single set for polar coordinates. We're gonna do this live cooking.
Hey there, welcome to another video. So in this video, I'm going to teach you about polar coordinates. Why, Leonard? Why do you have to teach me about a whole new coordinate system? I just got a handle on X, Y, like really good, and you're going to go screw everything up and tell me about something brand new. Why do we do that? Why do we teach you something like X, Y coordinate plane and then all of a sudden throw something like polar coordinates at you? You go, hey, learn this too. This is fun.
Sequentially
Fun,
in October,
but honestly,
58.4,
it's
57.0 on the service
what happens
PMI.
later on in
That
math
is a bit
is
less
that
than
polar
expected and
coordinates, what I'm going to teach you
sequentially
today,
less than
can
October's
actually make a lot of your
58.7.
math
And if we look at the
easier,
composite,
especially in calculus 3, some parts of
56.5
calculus 2.
also a miss, and
Sometimes
sequentially lower than our
graphing
last look at
polar coordinates is a whole lot easier than
57.6.
X
Now
and
our
Y.
PMIs are closer
Why?
to 60 than many of the
Because
European
for
PMIs
things
that came out today, but they
functions
did
that don't
all
pass the vertical
accelerate
line test,
sequentially
they actually
ahead of
become
their
functions
October
using
reads.
polar
We want to pay
coordinates,
close
which means we
attention
don't
here
have to
as
break it up and
30-year
graph like
bonds are
piecewise
hovering at
functions,
2%,
which is really
and
annoying.
10-year note
It
yields
also
are
makes a
hovering
lot
at
of calculus easier for certain
1.64%.
shapes. Things like
Shepard Smith
spherical
here.
coordinates,
Thanks for
things
watching
like cylindrical
CNBC
coordinates are based
on
on
YouTube.
this idea, polar coordinates, and then we extrapolate from there. So learning this, number one,
I
can
guess
be a
you win,
very, very
Leonard.
useful tool now. Can let you graph things that aren't even functions in X and Y, but are in polar coordinates. Can make certain things in calculus 2 and 3 a lot easier.
The game is
that's
to
what
just
we're
put
learning.
the
So what in the
A,
world are polar coordinates?
A equals
Polar
A, A
coordinates are a
equals
way to
B,
graph
A
points
equals
without using X and Y in a
U,
rectangle, but
A
instead
equals
an angle and a
X,
distance.
UVW,
And so here's the important
XYZ
things to know about polar coordinates.
variable.
Polar coordinates have
Well,
something called
you'd
a
think
pole,
they'd be the same,
acts
but
like an origin,
you could just
and
do
the polar
that
axis
random
acts
for
like the
this
x-axis.
random, or just
And
don't
from
totally
there,
off the
we can
rails
go
XYZ
positively
random order to
or
the
negatively a certain
W
angle, and then from that
boson,
pole, a distance
photon,
out, positive
gluon,
R
W
or
boson, Z
negative
boson,
R.
gluon.
So the key features here are the
Maxwell,
polar axis is a
Faraday,
whole lot like
Maxwell,
the x-axis.
Faraday,
It's
Gauss
a horizontal line,
curvature,
but it does
pipes.
definitely have
So
the
it could
starting
be
spot,
any of
this
these
pole
quadrants
that
at
we
any
treat kind of like an organ.
differential, especially if
So
we
how
started
polar
with the
coordinates work
information
is an order pair,
conservation
just like X and
information
Y, but
paradox.
instead of X and Y,
To
it
say,
gives you a
yes,
distance
he
from
is
the
giving
pole.
you the limit of
That
the
point
singular
gives you a
frame,
distance from that point along
here,
a certain angle
which
that
is
that point makes
both
with the
front and
X
back in a
axis or the
collapsed
polar axis.
manifolding
If we take
step
a ray and go
mechanic,
up
and that's
an
the
angle.
problem with
So
it.
basically we say,
Multiple
hey,
steps
here's where
happen
you
at the same
start,
time, but you can
go
only
up a
observe
certain
one
angle and then go out
at
that
a time,
distance, and
so you have to rely
reach a
on
point.
the
Notice
math
how
of
with a
singular.
given angle
You watched a
and a certain
photon
distance r, you'll get a
in
given
high
point.
speed. Now you
We
can't
don't
track
get
it
like
with the
several
high
points
speed
here, we get
camera,
one point
but if you
for a
time the
given
high
angle
speed
and a
camera
certain
with a
distance
pulse
from
of
the
light,
pole.
you can
So
actually catch the light
we're
in
going to
its
practice the
position
heck out
by
of this. There are a
knowing
lot of
the
examples.
speed of
But
light,
here's some things to
where
remember.
the pulse should
I
be.
hope that you remember that
But you could just take
positive
high speed
angles
camera and just
are measured counterclockwise, and the same thing happens here. If
they
we have
would
a
look the
positive
same in
angle, we'll measure
superposition
it
polarized.
counterclockwise from a polar axis.
By
Negative angles are
rotation,
measured
click, click to here.
clockwise, so we measure clockwise from a polar
Remember,
axis.
FMA, an
Positive
object in
R
motion is going to
is
remain
a
in motion
distance
unless
from
acted
that
upon by
pole
another object.
along
Problem
that
is,
ray that
it's
you
never
make, really,
zeroed,
from the
absolute
polar axis.
zero.
So use our
It's usually
angle
acting,
counterclockwise
being
for positive,
acted upon
and then from there,
away
R
from
is
a
the distance along
45.
that ray
Once I generalize
from
it,
that
you would
pole.
say, okay,
Negative
I
R
did
would
generalize the
be the
corner of the
distance
farm
along
here.
that ray in the
It's on an
opposite
angling
direction.
angle, so that
And
means
so
there's
we
another
measure
angle
basically
here to
positive
the
R and then
quadrant of
reflect it
steps, and
about
it's
that
going to be
pole.
on a
So
hill.
we're going to practice right
But basically,
now.
Mario
One of
can
the things
run
to
out
remember
here.
is that this ordered pair, while it is ordered, it's not
And
X
helping
and Y, it's
diagnose
R,
what
the
that
distance from the
wave
pole,
function
and
is, you'd
theta,
say,
which
well,
is the angle
how does that
connected
really
to the
do?
polar
Well, you'd have
axis.
to ask
So
yourself,
let's try a few of
doesn't
these things. How
those
about like 2 comma pi over
service
4?
problems come up in actions,
One of the
split
things that you
distance,
used to hear
and
is just
split
really the
places
layout,
in the
like what
middle,
the coordinates
maintenance
actually mean.
rotation,
So when we read
service
2
that weren't
comma pi
calc,
over 4 and we say these are in
they
polar
weren't
coordinates,
stepped out,
the first
they
number we
weren't
come to is the R, is the distance from that
reference
pole.
is a
Now I want you
fundamental
to really
force
recognize that
in
positive R
form,
is going to be
zeros and
measured
ones.
along
There's a way
the
you talk
angle
about
that you just
if the ones
have right
and
here.
zeros
Negative R will be
equal
measured
42,
along that
it
angle in
should
the opposite direction of positive
be
R. And so
congruent
we'll talk about that
with
when we get to those those negative R's.
The process?
The second number you get is an angle with
Project
that polar
Montauk?
axis. So positive means counterclockwise, and negative means clockwise.
Mikowski's
the first thing I do
is
all the time
right
in
there.
polar coordinates is really look at my angle.
And really,
and
this is
find
the
out
hardest
where
point
I'm
of the
at
map,
first.
because you
So
know
if
you
I'm
have to start
talking about
here, and you
positive
would definitely
pi over 4,
end here
and this is my
as
polar
the whiteout
axis.
read. I mean, whatever he's going to put out here for X's and O, tan arm
And that's the pole.
yellow arm.
Then I'm talking about from that axis going
in a bubble with
counterclockwise.
singularity out there.
That puts us
Andromeda,
about
Milky
here.
Way,
I'm also going to show you how to
Milky Way,
do some of
Andromeda.
this on a polar graphing system. So you can find that sort of graph paper, so like a graphing with polar coordinates, and it pops up. But from here, we're going positive or counterclockwise pi over 4. It's about right there. So I know that my angle.
So you are a photon and drunkard's walk problem. Trying to figure
is
out
given by that number, the second coordinate in our polar
Well, the problem with
coordinate
graphing is you get a lot of
system.
artistic
So that order pair says this angle you make
directness
with
with
polar
it. You
axis.
know what I
I've
mean?
just
It's like,
done
well,
that.
how do you
Now,
want? What angle do you
that
want to describe
ray
Mario
that
from?
You have just created,
What speed?
you're
What
gonna go
causal?
2
What
units.
general Bernoulli?
How in the world are you supposed to judge 2 units?
Hey,
Right now,
firstly,
you're just kind
do
of
one,
estimating
and then
or
me and Leonard are going to
approximating
mull
two.
over
On
it for a
that,
little
you can be
while.
very
and
accurate, so I'll
we're
show you
all
that in
going to
just a
make the
minute.
decision.
But we'd say, okay, let's imagine this is 1 and this